The earlier methods we learned, which rely on the inspection, are unsuitable for many functions. For example, we cannot see an example like x plus 1 whole power 4, right? Not everybody can always remember what is happening to this, right? How can I understand the given function, which was like 4x power 4 and 6x cube, all that was there. And how will I, even in my dream, remember that as 1x plus 1 whole power 4? Not possible, right? And also, I converted a lot of trigonometric functions in another form. This happens to only some of the functions, where every single function, I know integral of secant square x dx, which is actually tan x, right? But what is the integral of tan x? I have a problem, right? Similarly, there are many functions where we cannot think about simplifying them in the other format. So what are we going to do? Is there any other approaches? That is where we understand different approaches for different questions, and we need to know that's a problem about integration. In differentiation, every function, if you know how to differentiate, we have chain rule, we have product rule, and we have quotient rule. So this applies to almost every function we come across, except some special cases like in inverse trigonometric functions, right? But in the inverse trigonometric function also, we did some substitution process to understand the integration, right, for differentiation of such function. Similarly, here also we have multiple approaches, and one such approach is integration by substitution. So what is integration by substitution? Say if there is an integral and that integral is of the form f of x into dx, whereas uh, that function x can be written as some other format g of t, and when you differentiate that dx, that might have g dash t into dt. So in the place of dx, if you have g of t, and in the place we can replace it, we can solve it. So this will be very clear to you when we take an example. Let me take an example quickly, or we can take it from this presentation itself. See this example we can take. There is a numerator which has 5x square x cube plus 5x. Let me rewrite this. So there is this integral where it is integral of x cube plus 5x square minus x divided by x square dx. Okay, so when you differentiate, when you divide them carefully, it is x dx plus 5 minus 4 into my x power minus 2 entire thing into dx. So we know how to integrate this. Integration of this is x square by 2 plus 5x minus 4 into x power minus 1 by minus 1, which will be simply x square by 2 plus 5x plus 4 by x, right? This is one way to do this. Is there any other way to do this? Is we can assume uh, maybe let me give a better example. Yes. So let's go to the question and see exact method. What is substitution? You'll realize better there. Yes. How are we going to use the substitution method? So this is the first example where I'm going to show you how to apply substitution in our integration. So there is a question: integrate e power root x by root x into dx. So it's a function of a function. So let me assume this as, let us take this, let's pay attention to this. I have a root x and I have a root x in the denominator. And what is the differentiation of root x? What is the differentiation of root x? 1 by 2 root x. Yes or no? Yes or no? Yes. So differentiation of root x with respect to x is 1 by 2 root x. So as I have this 1 by 2 root x here, I want to solve this question in such a way that if I substitute this with some other variable, For example, let us assume, pay attention to this, let us assume root x as some t. Now differentiate with respect to t. What happens is 1 by 2 root x with respect to x we are going to do, okay, is equal to dt. So 1 by 2 root x dx is equal to dt. That means in the place of dx and by root x, we need to have what? 2 dt. So remember this. This is the first statement and this is the second statement. So now we are going to apply these two equations in the given question. So what happens to this question is e power t, and what is this is what we have left out, right? So that is equal to what? 2 times dt. Now 2 is a constant which I can take it outside. It is e power t dt. So when you differentiate now, integrate with respect to the variable t, so it remains as e power t plus a constant. But now our question is in terms of x, our answer is also in terms of x. So we replace the given question by this, that is, it is simply e2 into e power x plus a constant c, even though all the options are not having the c, so we can ignore that. So what is our answer there? Our answer is simply option, which option it is? C, 2 into e power root x. This is a very, very interesting method to solve any integrals if ever, wherever you can substitute and get it. But you need to be making sure that when you substitute that, what value you are substituting with respect to another variable. And when you differentiate that, you should be able to connect it to the remaining part of the variable or function which is not being substituted, has to be replaced by this differential. Okay, I know it is again too much. If you don't understand all the concepts and practice well, it will be very hectic. So please practice more and more questions like this. Okay, so the only way to ace this topic is to practice, re-observe and revise all these concepts, starting from trigonometry concept, logarithms, inverse trigonometry, and differentiation. So when you know all these things, then only integration becomes easy. Okay, sir, I want to learn integration only. That means that is not possible. When you want to learn integration, you should know differentiation, inverse trigonometry, logarithms, as well as trigonometry. Okay, yes. Let me go to the next question. So here we have, now I'll give you some time. I want you to solve this. This may be easy for some of you, or maybe difficult for some of you, or maybe neither easy nor difficult or indifferent to most of you. So please tell me how to solve this. Think about it. You have to be very smart enough to convert this into substitution form. I'm telling you, it's possible only if you observe carefully. Okay, so I'm trying to do this. I have this, right? So I'm trying to take root x common from the question, given statement in the denominator. So I now end up with root x plus 1 into dx. Now I'm going to take that root x plus 1 as t. Let root x plus 1 be t. So when you differentiate this with respect to t, we get 1 by 2 root x into dx is equal to dt. Okay, so now I know I have in the question 1 by root x into dx, which has to be now 2 dt. What happens to my question is, it remains simply 2 times dt divided by t. Okay, so let me take 2 outside. Let me write it here. And integral of 1 by t into dt is how much? Is actually logarithm of t plus c. So let 2 be as it is, logarithm be as it is, but in the place of t, what we should do? We should replace it by our root x plus 1 entire thing plus c. So which option is that? So we don't have again plus c in the question. So the answer is Tell me correctly. It is 2 logarithm of 1 plus root x or 1 by 2 logarithm of x plus root x, which is option C. It is 2 times logarithm of 1 plus root x plus a constant c. I hope I'm clear with this. Yes. Let me go to the next question. Another interesting question to start with. So now please recall what we did in the previous question and then try to solve this. Okay. Think about it carefully. I'll give you some time. And remember logarithm rules as well. Integral of, differentiation of logarithm will also help us. We can solve this question by substitution method. That's why we are having this example under this topic. Any questions, any doubts, you can again put it in the chat. Yes, what we can do, can you tell me? First, rewrite this as 2 times logarithm of x by x. Very good. Now let us assume what what is the integral of log, what is the differentiation of log x? What is the differentiation of log x? Tell me. D by dx of log x is what? 1 by x. That's why let us assume log x be t. When you differentiate 1 by x dx is equal to now dt. Okay, so now my question becomes 2 times, yes, t dt. Now let's t be as it is. It becomes t square by 2, right? So 2 cancels. We end up with plus c. What is t square now? T is nothing but logarithm. It simply becomes logarithm of x whole square plus c. So it is not logarithm of x square. It is logarithm of x whole square. Which option is it? That is option A. Okay, so is this clear now? I know it may be very confusing for beginners, obviously, but once you start practicing this, you will only understand the approach, because every question in the exam may not be something which comes from the actual textbook. They might come with the new questions with the same approach. So you should be able to observe them. That means solving only textbook questions is not going to help you ace that kind of questions, right? Right, not memorizing or not just solving, practicing the same questions again and again, but to understand and remember while practicing the different approaches for different questions. Yes, let me erase this. Let me go to the next question quickly. What do we have here again? Now I want you to think in the same way we solved the previous question. What can we do to this? Sin x plus cos x into dx. Is there any way we can substitute something so that I'll get the answer faster? Look at the options also. We have 2 options as the logarithm possibility. So can we think about it? Yes. So someone is suggesting me to take the denominator as t. What is the denominator? Anonymously, someone is messaging. So that's the right method. So let us assume the denominator sin x plus cos x is equal to what? T. Now differentiate this. When you differentiate, what we get? Cos x minus sin x entire thing into dx is equal to dt, right? But what we have the numerator is sin x minus cos x. That means the numerator is minus of dt. Okay, the denominator is now t. It is minus 1 by t dt. So let's keep the minus as it is. So it is log t uh, plus c. So it is logarithm of t power minus 1 plus c, which is simply logarithm of 1 by t plus c, because a power minus 1 means what? 1 by a. Yes. So finally, we are going to replace the t by what we assumed. What we assumed is t as what? Sin x plus cos x. See, beautifully, this is equal to our option C, right? Which is 1 by logarithm of 1 by sin x plus cos x, right? Isn't it interesting? Obviously, it has to be interesting only if you are following all the steps correctly, learning all the concepts in the right order in which our syllabus is designed, right? Yes. Let me erase this. Let me go to the next question. Question number 5. Similar question. Now I expect you to solve this, and you have to choose the option. Okay, very similar to previous example, so it is not difficult at all. If you have paid attention to the previous one, try this. Again, logarithm is there, and I'm giving you a clue. It's again a substitution question. When method by substitution, we can solve this. What will you assume? Yes, absolutely. Let us assume the denominator 2 cos x plus sin x as t. Differentiate on both sides, we get 2 sin x minus cos x into dx as t, dx as dt. So our numerator is equal to this only, right? That means our question becomes simply 1 by t dt. So that is simply logarithm of what? T plus c. Simple. So which has to be logarithm of what is the assumption we did? 2x, right? It is logarithm of, yes, sin x plus 2 cos x. Nothing apart from this, which is option A itself. Right? Plus C is missing. That means they're ignoring the constant part, because all the options, none of them have plus C. Right? So that's all about this question. Isn't it now making sense? Yes, because we solved similar question already, right? So I have 4 more questions to finish from this substitution. By the end of these 9 questions, you should be able to uh, understand the approach very well. Okay, so let me erase this. Let's go to the next question quickly. Yes, so what do we have here? Sin x. Sometimes the functions are designed in such a way that it is easy for us. We need to know only where to observe, where to substitute what. So I have sin x into e power cos x dx. Okay, so what should I assume? Whenever the exponential function is there, remember integral of an exponential function is also same plus a constant, whereas differentiation of this exponential function is also same function. That is why we will not replace entirely exponential function with something, because that will make the problem difficult. So what we can do is keep the exponential function, but we remove the variable part of this as t now. Let cos x is equal to t. Now when you differentiate, you definitely get this one. But I get minus sin x dx is equal to dt. Now what happens to my problem here is, this is sin x dx should be equal to minus dt, and e power cos x will become e power t. So my problem become e power t into dt negative sign, right? And that is going to be e power t plus c with a minus sign. So now what is e power t? E power t is minus e power what? What do we have observed? Yes, it is e power cos x plus c. Right? Any question in this? Hmm? It is minus e power cos x plus c. which is not there in the option. So the answer must be what? Think about it. Answer must be none of this. Right? Yes. Let's go to the next one. Three more questions to go. Now tell me what is the best variable to substitute, or which part of the function should be substituted. Obviously, the root x can be substituted because I'll get 1 by 2 root x, so I can eliminate this denominator part easily. So when I differentiate, it is 1 by 2 root x dx is equal to dt. So the given dx by our problem becomes cos t into 2 dt. The 2 can be taken outside. It is cos t dt, and integral of cos t is sin t plus c. So 2 into what is c here? Sin root x plus c. So that means the answer is option D, 2 times sin root x. Okay, plus c, which is option D. Am I right? Integration by trigonometric identities. So what are we saying here? So integration by trigonometric identities is a technique used in calculus to simplify the integrals involving trigonometric functions. For this, what is the basic necessity? The basic necessity is you need to know the trigonometric identities. So what are the trigonometric identities we know? The basic one is a result of Pythagoras theorem. Sin square theta plus cos square theta is equal to 1. Right? Yes. And then when you divide this entire equation by what? Sin square theta, what we get? When you divide this entire equation by sin square theta, what we get? Tan square theta plus, what is it? When you're dividing by cos square theta. So when you divide this entire equation by cos square theta, we get tan square theta plus 1 is equal to what? Secant square theta. To make it very simple, we can keep everything on the left side and 1 on the right side like a previous one. Secant square theta minus tan square theta is equal to 1. That is second equation. If we divide the entire equation by sin square theta, what we get is 1 plus cot square theta is equal to cosecant square theta. So that means cosecant square theta minus cos square theta is also equal to 1. Okay, so just remember this. These three identities are going to help us in many places. Apart from that, what else we need to know? That is sine of a plus b. What is sine of a plus b? Sine a cos b plus cos a sin b. That is some of the two angles. If I have minus sign, this will become minus. Similarly, what is cos of a plus b? That is cos a cos b. If there is a plus, we'll have minus. Sin a sin b. This has to be remembered directly. So if there's a minus, we'll have plus. Okay. Similarly, what is tan of a plus b? Tan of a plus b is tan a tan b divided by 1 minus tan a into tan b. So if there is a minus, we'll have plus here and we'll have minus here. Okay. Similarly, you can think about secant, cosecant, and cot. Even if you don't know, we can get it from the basic formula. Okay. So by this default formula, I can say sine 2 theta. By replacing a and b by theta, we get double angle formula is 2 sine theta cos theta. A quick revision of trigonometric identities we need to know. Okay. Similarly, cos 2 theta is cos square theta minus sine square theta. We already used this identity today's class itself. I can replace everything by cos square theta by writing sine square theta as 1 minus cos square theta. It will become 2 cos square theta minus 1. Okay, it can also be written as 1 minus 2 sine square theta. Okay, right? So we can write like this. So because of this relation only, I can write cos theta in terms of sin theta as well as cos theta. How? See, I'm going to use the same method to write cos theta in terms of cos 2 theta as well as sin theta in terms of sin cos 2 theta. That is, if I use this one, cos 2 theta. So what is cos theta then? Cos theta is equal to 1 plus cos 2 theta divided by 2 square root. Am I right? Yes. So what is sin theta then? Sin theta is in the place of plus we have minus, that is 1 minus cos 2 theta divided by 2. Okay. Yes. That means I can also use this to write tan theta and cosecant theta, right? So it's a very interesting formula and multiple uses that has a versatile application. Okay. Now, by replacing this 2 theta by theta and theta by theta by 2, we can think about half angle formula as well. Whenever it is required, we can use them. Okay. So for now, for time being, this much is enough. Along with the triple angle formula, what is sine 3 theta? Sine 3 theta is 3 sine theta minus 4 sine cube theta. What is cos 3 theta? Cos 3 theta is 4 cos cube theta. This also we used, if you can recall this, 3 cos theta. Okay, so this much is enough for now. So let's get any other identities if we are coming across, we can discuss them in detail. So using all this, we may have to convert the given functions in the different formats. Okay, so let's see. Yes, all the identities which I discussed right now is here. Yeah, so I did not discuss about tan 2x. You can see what is tan 2x, right? So sine square x, there is a pictorial representation to remember this. If you can use this, you can say, you can write in the hexagonal form sine cos and then tan cot and then secant cosecant. So yeah, this is another way to remember. So sine square x plus cos square x is equal to 1. 1 square x plus cot square x is equal to cosecant square x. And then tan square x plus 1 square x is equal to secant square x. This is the way to remember, and you don't have to by heart this. If you know what way did it come from, it is very easy. In case if you remember, if you think this is very easy to remember, you can use this as well. Okay. Yes. Again, as I discussed, there is an example already. They're asking us to integrate cos square x dx. And we know how cannot integrate something like this until it is secant square x, okay, or cosecant square x. Other trigonometric functions, we don't know how to integrate directly, right? These are the only two trigonometric functions in the square format. We know their integral, right? That is the reason I have to first rewrite this cos square x in some other format, which is not, any other, which is, if it is of secant square x or cosecant square x, we can directly get the answer. Apart from that, we cannot use a square format. So how can I reduce the degree to 1 is by using this formula. Cos square x is nothing but what? Cos square x is 1 plus cos 2x divided by 2. Now I can integrate this separately. 1 by 2 into dx plus cos 2x into dx. Now what is 1 by 2? 1 by 2's integral is x by 2 and cos 2x is sine 2x divided by 2. Isn't it? Yes. So our answer will be how much? So it is again divided by 2 further. So it has to be, final answer is x by 2 plus sine 2x by 4 plus arbitrary constant c. Okay. Yes. Coming to the last question in this section, we have to integrate 1 plus sine x by 2 dx. So what will you do? So somehow I don't know how to integrate something in the square root. So I want to eliminate the square root. So what I am going to think is, I'm going to think about this question as square root of sine square x by 4 plus cos square x by 4 plus, looking at the options is helping me as well. 2 into sine of x by 4 into cos of x by 4. Entire thing into dx. Why? Because one thing we know, sine square theta plus cos square theta is equal to 1. Right? So another thing is sine theta, 2 times sine theta into cos theta is equal to what? Sine 2 theta. In this problem, theta became x by 4. So 2 theta became x by 2. So my problem now became sine x by 4 plus cos x by 4 whole square root into dx. Because it is in the form what? A square x plus, a square plus b square plus 2ab format, which is expansion of what? A plus b whole square. See how many identities we need to know to get this right, right? Is it difficult? I don't think it's difficult if you have understood and remember all this properly. Okay. So now my problem is simply sine x by 4 into dx plus integral of cos x by 4 with respect to x. Okay. So what is integral of sine x minus cos of x by 4 divided by 1 by 4 plus what is integral of cos x? Sine of x by 4 divided by 1 by 4. So taking that 4 to the numerator, we get minus 4 cos of x by 4 plus 4 sine of x by 4 with an arbitrary constant c, which is not there in the option. So we can ignore that right now. So tell me which is the right answer. You may end up writing everything right with a small mistake in the sign that will also give you 0 marks. Okay, so that is why be careful because it's a multiple choice question. By mistake, if you miss out this sign, you might go for option D, which is not correct. The right answer is what? Option C.